Hello everyone. So today I'll be discussing about my paper based on feature selection algorithms. It is a comparative study. So the paper ID is 43. My name is Samod Srinivas. So the agenda today is problem statement followed by abstract, literature survey, the proposed methodology, model building, results, and finally with the conclusions. So the problem statement is the main aim of this paper was to do a comparative analysis of different feature selection methods that is present out there. So after going through the paper, anyone who is new to machine learning or would like to know more about feature selection would gain a basic understanding of different feature selection methods and when to use which method. So the abstract coming to the abstract part. So with increase in social media usage, the companies are collecting data without focusing on whether the data that they are collecting will be of use or not, but they are collecting data in huge amounts. So like while they are developing any useful information out of those data, it becomes important to select only the features which contribute to that particular prediction or output. So feature selection plays a major role there. So in this paper we'll be discussing about different feature selection methods like forward selection, backward elimination, recursive feature elimination, correlation, ANOVA, tree based method, and all these are implemented on top of XGBoost model. We have used two dataset, vehicle on default dataset and Parkinson dataset, to do the comparison. Literature survey, as these models are not new models, there are quite a large number of papers available as part of literature. Here we have mentioned four different papers contributing to the four different subsections which we have chosen. And the first paper talks about using gradient boosting for feature selection. The second paper talks about using ANOVA method for feature selection. The third paper here, it talks about the common methods like for forward selection, backward elimination, and RFE. And the last one talks about the embedded and hybrid methods that can be used. So coming to the methodology which we have implemented here. Forward selection, this is a greedy search algorithm. So it initially starts with one feature and continues its subspace until all the features are included, and out of those combinations whichever is giving the best result, it gives that as the final features. Contrast to this, backward elimination is just opposite to it. It starts with all the features and reduces features one by one until there are no features left to remove. Recursive feature elimination, this works same as backward elimination, but the only difference between the first two method and this method is there it makes use of a single method. It takes the performance score like accuracy or F1 score, and based on that it will decide which feature to drop for the next iteration. But in recursive feature elimination, it makes use of inbuilt values like feature importance scores to select which feature to drop for the next iteration. Apart from that, this works same as backward elimination. Next is correlation method. Here the concept is if two features are highly correlated, then one feature is enough to explain whatever the data is there, so the other feature is just a redundant feature. So and for our study, whichever coefficient value is greater than 0.8, we have removed one feature out of the group of features. ANOVA method, this makes use of concept of variances. If the variances are different, then it belongs to two different groups, otherwise it belongs to the same group. Next, gradient boost and XGBoost. So gradient boost we have used in hybrid method where we select the features based on output of gradient boost, and then that is fed to XGBoost to get the final performance metrics. Coming to XGBoost, this is the base, as I mentioned earlier, this is the base for all the methods for the comparison. It makes use of the tree based approach to it is an ensemble method, and it performs quite well compared to different classification methods. Coming to the metrics that we have chosen, the data set which we had imbalance in the data, so it is not ideal to rely on accuracy or F1 score or precision scores. So we have chosen ROC AUC score so that there is no bias towards the count of the target in the data. So coming to the model building, the data set that we have one vehicle loan default dataset which has 41 features of 1,12,661 customers. And the second data is about Parkinson disease classification. It has speech recordings of 188 patients with Parkinson disease and 64 normal patients. These recordings are repeated 3 times and they are classified as Parkinson patient or normal patient. So this is how the data distribution is. You can see at the bottom. There is no class imbalance in Parkinson data, but in vehicle loan default there is class imbalance that we'll be handling in the coming slides. So coming to the pre-processing technique, the data had many ID columns and flag columns, which having them in the data would induce bias in the decision making. So we have dropped those columns, and missing values, we had one column which is employment type had 6% of missing records. So instead of just dropping those records, we have imputed using KNN imputation with different number of neighbors, and from the graph we can see that when 10 was chosen as number of neighbors, we got the best result. So going forward with k equal to 10, we have imputed the missing records. As part of feature extraction, we have combined two different columns to get the age of the customer, and also we have cleaned two particular columns which had data of year and month, and we have only made it in months. Coming to encoding, we have one column which is credit score description. We have used 1 hot encoding to convert it into categorical to numerical. As part of sampling, as I mentioned, there was imbalance in the data. We have used smooth to increase the minority class count. After sampling, the minority class percentage was majority to minority class percentage was 60 to 40%. Coming to model building, first we have done sequential forward selection, backward elimination, and recursive feature elimination with fivefold cross validation. Then ANOVA, and then correlation, and later tree based method where XGBoost was used to select features and GBoost for classification, and later we noted down the ROC AUC scores and arrived at our final result. This is our result. So comparing these two tables, we can see that in both the data set, recursive feature elimination was best when compared with other methods, because it provided a balance of good ROC AUC score along with the least number of features and also the execution time. Next, coming to the individual process plots. So we have plotted the individual graphs for every method that we have chosen for both the data set. So basically what we derived from these graphs is that since these outputs that we get are from Python methods, we need not entirely rely upon those methods, because from the graph we can see that with even less number of features we could achieve almost the same performance, because the method would take even a slight change, even in decimals it would consider to give the best score. So that is what we have seen from all the graphs that I would show in future slides also. So the baseline is that we can get the same performance with even less number of features. Backward elimination for data 1 and data 2, recursive feature elimination for data 1, similarly for data 2, ANOVA. This is the hybrid method. the correlation which I mentioned. Here we have only displayed correlation greater than 0.8, and this is the final result. Like data 1, the least number of features selected was by tree based method, and the highest score was given by tuned XGBoost. But in both the models we can see that RFE is the second best, and it is giving a balance between score, number of features, and execution time. So as part of conclusion of this paper, we can conclude that feature selection is an important step in ML lifecycle. It conveys an important message that just by increasing the number of features, it does not help to increase the performance. Only the relevant features will add meaningful insights. And then in our analysis, as I mentioned, RFE proved to be the best performing model for both dataset, resulting in high performance and reasonable execution time. So if we need a quick understanding of which features are important, we can go for filter methods like ANOVA and correlation. But the best method to go for when we have big data at hand is recursive feature elimination. It is not advised to go for sequential forward selection and backward elimination, as they take huge execution time. So these are all the list of reference papers that I have referred here. So thank you for giving me an opportunity to present at this conference. Thank you.